Consider our earlier example of the company wishing to estimate the proportion of households with a digital television. How large a sample would the company need to take to be 95% confident that the error in using the sample proportion to estimate the true proportion is at most 4/100ths? If the company knows that the proportion of households with a digital television is at least 55/100ths. Let's start this problem by first identifying the type of confidence interval that we need, and that is 95% confidence interval. So that tells us that our critical value, or Z star in our case, is 1 in 96/100ths. The next thing that we know in the problem is that the error in using the sample proportion to estimate the true proportion is at most, which means less than or equal to 4/100ths. So that's our margin of error. So we have less than or equal to our margin of error. And the margin of error is found by taking our critical value Z star and multiplying it by the square root of p hat, our sample proportion, times 1 minus our sample proportion p hat, all divided by n. Well, we know that our critical value Z star is 1 in 96/100ths, so we can substitute that in, times the square root. Now, do we have our sample proportion in our word problem? The company knows that the proportion of households with a digital television is at least 55/100ths. This is our sample proportion, or p hat value, so let's substitute that in. So we have 55/100ths, and then 1 minus 55/100ths is going to be 45/100ths, and then divided by n. Now what we can do is we can multiply both sides by the square root of n, that will cancel this part of the fraction out on the left side, and we can also divide both sides by 4/100ths to move that to the other side. So now we have 1 and 96/100ths divided by 4/100ths times the square root of 55/100ths times 45/100ths, and that's less than or equal to the square root of n. And now we can square both sides of our inequality. Square, square. Then we're going to have to distribute the square through to both terms, so we'll have 1 and 96/100ths divided by 4/100ths, quantity squared. Now the squaring undoes the square root, so we just have 55/100ths times 45/100ths, and that's going to be less than or equal to n. And now we can substitute this expression into our calculators and get an answer. And we end up getting, when we substitute this in, 594 and 2,475 thousandths. So we could round that up to 595. And because we have, so our n $594 and change, we can round that up to 595. So n has to be at least, because it's greater than or equal to. So that's answer choice C.